If you've ever seen an ice cube float in your drink on a hot summer day, or perhaps in a glass of water, you've witnessed a fascinating phenomenon. This simple act of floating is a perfect example of the science of buoyancy at work. On the other hand, if you've ever tossed a rock into a pond and watched it sink straight to the bottom, you've also encountered buoyancy, but in a different way. Buoyancy is the science behind why some objects float while others sink. It's a fundamental principle that explains so much about our everyday experiences with water and other fluids. It all starts with a force called upthrust, which is the upward force exerted by a fluid like water on an object. This force is what allows objects to float. When you push an object into water, you can feel the resistance. This resistance is the upthrust, pushing back against the object. The stronger the upthrust, the more likely the object is to float. Imagine you're at the pool, enjoying a sunny day. You decide to play with a beach ball. You hold the beach ball underwater and immediately feel a strong push trying to bring it back to the surface. This push is the upthrust in action, working to make the ball float. When you release the ball, it pops up to the surface quickly. This is because the upthrust is greater than the weight of the ball, causing it to rise. Now the secret sauce of buoyancy is density, which is how much mass is packed into a given volume. Density determines whether an object will float or sink. Density is a measure of how tightly matter is packed together. If an object has a lot of mass in a small volume, it's dense. If it has less mass in the same volume, it's less dense. If an object is less dense than the fluid it's in, it floats. This is why a cork, which is very light and not very dense, floats easily on water. A cork is super light and super floaty because its density is much lower than that of water. It's almost like it's designed to float. But if it's denser, like a rock, it sinks. Simple as that. A rock has a high density, meaning it has a lot of mass packed into a small volume, so it sinks in water. It's why ships, even though they're heavy, float. They're designed to displace enough water to create a strong upthrust. The shape and structure of a ship allow it to push away a large volume of water, creating enough upthrust to keep it afloat. Ships are marvels of engineering, carefully crafted to balance their weight with the upthrust from the water. This balance is what keeps them from sinking, despite their massive size and weight. Next time you're in the bath or the pool, take a moment to think about the incredible science keeping you afloat. Whether you're floating on your back in a pool or watching a boat glide across a lake, buoyancy is at work, making these experiences possible. Buoyancy isn't just for boats and balls, it's a fundamental force at play in our world. From the smallest leaf floating on a pond to the largest ships sailing the oceans, buoyancy is a key player in the dance of objects and fluids. It's also crucial for marine life. Fish and other sea creatures rely on buoyancy to move and survive in their watery habitats. The balance of forces allows them to float, swim, and dive with ease. So, stay curious and keep exploring. The more you understand about the world around you, the more fascinating it becomes. Science is everywhere, and buoyancy is just one of the many wonders waiting to be discovered. Science is everywhere.